Assalamualaikum and hi to everyone. Thank you for watching this video. Please subscribe, like and share. In this video, we will discuss about the data rate limits. So data rate limit refer to the how fast we can send the data in bit per seconds over the medium or the channel that available. Data rate is depends on three factors. The first one is the bandwidth available, how bigger your bandwidth size that we have. Second, the level of signal that we use. And the third one is the quality of the channels that we use. It's the quality of the transmission medium that we use. The level of the noise of that channel or the level of noise of the transmission medium. So different channel that we use will affect our data rate. So there are two theorem or two formula that will be discussed: Nyquist bit rate and the Shannon capacity. So based on that formula, we calculate the bit rate. Okay, Nyquist theorem is based for the noiseless channel. Nyquist noiseless. And then Shannon capacity for the noisy channel. Shannon for noisy. So you need to remember that Nyquist for noiseless, Shannon for the noisy channel. So based on noiseless channel and Nyquist bit rate theorem, in order to calculate the bit rate, we must twice the bandwidth times the log level base 2. So bandwidth is the bandwidth of the channel. How big the size is based on the channel type. And L is referred to the number of signal level that used in order to represent the data. So one level, how many bits of the data. So increasing the level of signal may reduce the reliability of the system. And this part, the system is referred to the communication system. Okay, we look for example number 1. So example number 1 asks about does the Nyquist theorem bitrate agree with the intuitive bitrate described in the baseband transmission? So the solution, okay, they match when we have only two levels. In baseband transmission, the bitrate is 2 times the bandwidth if we use only the first harmonic in the worst case. However, the Nyquist formula is more general than what we derive intuitively, so it can be applied to baseband transmission and modulation when we use the transmission of the baseband and do the converting operation or process. And also it can be applied when we have two or more level of signal. So it means L equal to 2 or more. So this one for example 1. Okay, next example, we consider that noiseless channel with the bandwidth 3000 Hz transmit a signal with two signal levels. So we have bandwidth 3000 Hz, we have L equal to 2. So we need to know the maximum bit rate that can be calculated based on the formula that being discussed before. So bit rate equal to 2 times the bandwidth times with the log level base 2. So based on this one, we have 3000 times with 2 twice, and then time with the log level 2. So it's equal to 6000 bit per second. So the maximum bit rate is equal to 6000 bit per second. The next example, we need to send 265 kilobit per second over a noiseless channel with a bandwidth of 20 kilohertz. So how many signal level that we have? So based on the Nyquist formula, 2 times the bandwidth times the log level. And now we have the bit rate 265,000. Okay, for this one, is equal to 2 times the bandwidth equal to 20 kilohertz, so 20,000, and then times with the log level is 2. So we need to identify how many level. So based on the formula, when we do calculation, a log L base 2 is equal to 6.625. So L equal to 2 power of this one. So it's equal to 98.7 level. So since this result is not a power of 2, we cannot get the even number. So we need to either increase the number of level or reduce the bit rate. So we can assume if you want to increase, we can put as 128 level. If we want to decrease, we can put as 64 level. So 2 power of 7 equal to 128. 2 power of 6 equal to 64. We can either increase or decrease the level. Okay, next part we go for the noisy channel. So noisy channel is based on the Shannon capacity. So in the reality, we cannot have noiseless channel. So the channel is always noisy. Logically and realistically, there's no transmission medium without any noise. Most of the transmission medium and all the transmission medium that we have, they still can capture the noise. But how trying the noise depends on the channel itself. So to determine the theoretical highest data rate, a capacity is equal to bandwidth times the log 1 plus SNR. So this one is based on the Shannon capacity for the noisy channel. So bandwidth is the bandwidth of the signal, SNR is the signal noise ratio. So example 1, consider an extremely noisy channel in which the value of the signal noise ratio, SNR ratio, is almost 0. Mean the ratio of the noise is almost 0. So in other words, the noise is so strong then that the signal is faint. So for this channel, the capacity C is calculated based on the previous formula in the previous slide. So capacity is equal to bandwidth times log 1 plus SNR is 2. So S and R almost 0. So you put 0 plus 1 equal to 1. Equal to B, bandwidth time log 1 is 2. So B times 0 equal to 0. So this means that the capacity of this channel is 0 regardless of any bandwidth, any number of bandwidths. The capacity is still 0 because 1 plus 0 equal to 1, log 1 base 2 equal to 0. So in other words, we cannot receive any data through this channel. Example number 2, we can calculate the theoretical highest bit rate of the regular telephone line. So a telephone line normally has a bandwidth of 3000. So this one is referred to the B. B is 3000. The SNR is usually 3162 signal to the ratio, to the noise ratio. And then for this channel, the capacity is calculated as we find the C. What is the capacity? So the bandwidth 3000 times with the log 1 plus SNR. SNR 3162. So plus equal to 3163. So 3000 times logs 3163 is 2. It's equal to 3000 times 11.62. So we get the capacity is equal to 34,860 bit per second. So based on this result, This means that the highest bit rate for the telephone line is 34.860 kilobit per second, or 34,860 bit per second. So if we want to send the data faster than this, we can either increase the number of the bandwidth. When we increase the number of bandwidth, let's say 3,000, we change to 5,000, we able to get bigger data. Or we also can improve the SNR. Either we increase the bandwidth, or we improve the SNR, or we improve both. So we can send data faster way. Okay, next example number 3. The SNR ratio is often the SNR is often given in decibel uh, or dB. In D in the small letter and then B in the capital letter. So we assume that the SNR dB equal to 36 and the channel bandwidth is 2 megahertz. So theoretical channel capacity can be calculated as SNR dB 10 log SNR 10. Okay, based on the previous formula, so SNR equal to 10 power of SNR dB divided by 10. So it's equal to SNR equal to 10 power of 3.6, and it equivalent to 3,988 decibel. Okay, and then for C, B, the bandwidth is 2 megahertz log 1 plus SNR. Okay, so 2 refer to the bandwidth megahertz, so times 10 power of 6 for megahertz, and then time the log 3982. This one is SNR here plus 1, so it's become 3,982. Then the final answer will be 24 megabit per second. Okay, next example, we have a channel with 1 megahertz bandwidth. The SNR for this channel is 63. What are the appropriate bitrate and signal level? So first, we use the Shannon formula to find the upper limit. So C capacity, B bandwidth log 1 plus SNR. So bandwidth is 1 megahertz. 1 times 10 power of 6 times log 1 plus 63. 63 refer to the SNR. So 64 10 power of 6 log 64 2 is equal to 6 megabit per second. So the Shannon formula gives us 6 megabit per second. So the upper limit are 6 megabit per second. So for better performance, we can choose something that lower than 4 megabit per second. Well, when we use the Nyquist formula, the previous one, we can find the number of signal level. So 4 megabit per second, 2 times 1 megahertz, so L base 2. So we will get L equal to 4. So the Shannon capacity give us the upper limit, and the Nyquist formula tell us about the how many signal level that. So this one, in order to get the L, the Shannon here tell us on the upper limit can send the data, the benchmark. Right. So that's all for the data. In part, you should just know what are the theorem. So the two theorem formula calculation based on the system, how to do the calculation based on the share. So, and assalamualaikum.